All right, so this is 10.5 part 1. So this is about angle relationships in circles. So we talked a little bit about central angles and the different inscribed angles last time. So this time we're talking about different line segments and kind of how that can affect it. So the first thing we're going to talk about is the tangent and intersected chord theorem. So a tangent, we know, is a line that's going to touch the circle at one point. And the intersected chord is saying, all right, so you have a chord somewhere in your circle, and that endpoint is going to be that point of tangency as well. So this theorem says that if a tangent and chord intersect on the edge of a circle, then the angle created is half the intercepted arc. So what am I talking about? So if they intersect, they create an angle. So that angle is half the intersected arc. So here, these are the two angles that have been created, angle 1 and angle 2. So the arcs they're talking about are here and here. These are the intersected arcs. So 2 is talking about this one, the pink one, and 1 is talking about the yellow one. So they're half the intersected arc. So the measure of angle 1 is going to be 1/2 of AB. We know we're talking about this yellow one because AB is just 2 letters, so you always go the shortest way. So for the next one, you're going to want to do, measure 2 would have to be half of ACB, so you know which one you're talking about. You could also call it BCA, doesn't matter, as long as you are hitting the right points in the right order. So let's kind of do some practice with that. So first, so what is the measure of angle 1? Well, it's going to be half this intersected arc. So that is going to be half of 130. So that's going to be 65 degrees. Now, what if I asked what angle 2 was? Well, these are making up a linear pair, so they are supplementary, they add to 180. So the measure of angle 2 would then be 180 minus 65. 180 minus 60 is 120, minus 5 is 115. Okay. All right, for this one, I'm saying, all right, what is the measure of arc LK? So this is what I am looking for. Well, it's not twice as much as this, it's on the wrong side. So this is a linear pair. So what angle should go right here? Well, 180 minus 125. That's going to be 55. So that's going to be twice as much. That is going to be 110. That's the different kind of ways we can use this. All right, the next is intersecting lines in circles. So if I have 2 intersecting lines, what are the different things that could happen? So if 2 non-parallel lines intersect a circle, so it's 2 lines are intersecting and some part of them are also intersecting a circle, then there are 3 possibilities where they can intersect. So what are those 3 possibilities? Well, they could intersect on the circle. So I have these two intersecting lines, and that point of intersection is on a circle. We could be inside the circle. So I have my two intersecting lines, and it's happening somewhere inside there. It's not always on the center. It kind of looks that way the way I drew it, but it could be intersecting anywhere that's inside. And then you could intersect outside the circle. So I could have these two intersecting lines. Maybe the circle is over here. So that intersection is an inside. So there's a theorem for if it's happening on the inside. So angles inside the circle theorem. So that is working with lines like this. So if an intersection is inside the circle, then the measure of each created angle, so it actually creates 4 angles, 1, 2, 3, 4. So the measure of each created angle is half the sum we get by adding, half the sum of the intercepted arcs. Of the specific angle and its vertical angle. So that is a lot of words. Let's break it down. So this is how to find, no matter where you drew those lines in a circle, how are we going to find the angle? Well, so each angle is half the sum of the intercepted arcs for that and kind of the opposite one, so that vertical angle. So here, for instance, angle 1, it's going to be half of these two because it goes right there as well. Those are vertical angles. So the measure of angle 1 is going to be half the sum, so half of AB plus CD. And likewise, angle 2, I'm going to get by, now, if I'm adding two things together and taking half, that's the same as finding the average. So the measure of angle 2 is going to be 1/2 BC plus AD. So that is how we can find angle measures no matter where it's intersecting, as long as it's intersecting inside the circle. You can kind of see this one isn't right in the center, but as long as it's somewhere inside, this theorem will work. So we have right here, so I want to find what x is. Well, it's going to be the average of these two, so half the sum. So x is going to be 1/2 of 130 plus 156. 130 plus 156 is 286, and half of that is 143. So that is the value of x, is 143. And remember, it should make sense. It should be to scale. This is definitely an obtuse angle, so we know it's between 90 and 80. All right, so now move on and please watch 10.5 part 2.